Lesson 17, Determinants and Inverses of Matrices. Things you should remember is that if we were to inverse a function of x, we would just get x. This is the same premise of inverses. So we're going to start off with multiplicative inverses. These are things that you learned back in middle school. So what is the multiplicative inverse of the following? Basically, what number would make, in this case, example A is 2. So what number times 2 would equal 1? The multiplicative inverse would be 1/2. For B, what number times 1/4 would equal 1? Well, the multiplicative inverse would be 4. For C, what's the number that would multiply -2/9 to give you 1? Well, that'd be -9/2. Your goal is to get 1. You want the identity multiplicative number, which is 1. Okay, so matrices lands. So we want to convert this system to a matrix equation. So right now we have a system of equations, and our goal is to make this look like some sort of matrix times the x matrix, or the ones with the variables, equals what it equals. So in this case, when we think about it, we want the first matrice. This is going to be, in this case, because we're dealing with a system of 2 variables, this is going to be a 2 by 2. We want this to have the coefficients of the system. So I think I spelled coefficients wrong, but it's okay. We want 3, -1, and then 2, -5. For the middle matrix, this is known as our X matrix. We're going to call this first matrix matrix A, and we're going to equal this to matrix B. Now, our X matrix is the one with all the variables. So in this case, we would have X and Y. And then the last thing, what this equals, well, it's going to equal -11 and 10. So you want to put it in the same order as the row you see the system in. So this would be how you convert a system into a matrice. Now, things you need to know. The identity matrix looks like this. They are square matrices. So notice this guy is a 2 by 2. This guy is a 3 by 3. This guy is a 4 by 4. And identity matrices are kind of like multiplicative inverses. They represent that number of 1, but with matrix things. So if you recall question number 11 from homework 16, we had you multiply some matrix, which was a square matrix, by the identity matrix of a 2 by 2. And when you did, you got the original of what you already had. So basically, if we have some matrix A, we multiply it with the identity matrix, we're just going to get A every time. And so this is something you definitely want to know. Okay, so in terms of inverses, how do you find an inverse of a matrix? Well, if we have a 2 by 2 matrix, a square 2 by 2 matrix, we are going to find these by hand. So first you have to find the determinant. So let matrix A be little elements A, B, C, D. The determinant of a 2 by 2 is calculated by writing the determinant of A, which equals, notice this notation looks like absolute value. No longer does it have the little bracket, but that means find the determinant. And to do that, you're going to take the multiplication of the diagonals. So you're going to multiply A times D. Notice that's the first term. You're going to subtract away the diagonal B and C. So it's AD minus BC every time. The determinant can only be found if the matrix is square. So if you have a rectangular matrix, like a 3 by 2, you can't find the determinant. Yes, you can find the determinant of a 3 by 3, but you would need a calculator for that, because we're not going to do that in this class. So to find the inverse, this is another definition. The inverse of a matrix is denoted as A raised to the -1 power. Notice this is like inverse notation, same thing as like functions. It's like our function notation, so like this is the same thing. This equals 1 over the determinant of A multiplied by the augmented matrix D negative B negative C A. So remember, A originally was A, B, C, D. If I'm augmenting it for the inverse, I'm changing the diagonals of A and D, and those locations switched, and I'm negating B and C. When would I not have an inverse of a matrix? Well, there's two options. One would be if the determinant of A was equaled to 0, because 1 over 0 is undefined. You can't have 1 over 0. So if the determinant of A is 0, you don't have an inverse. The second time you wouldn't have an inverse is, by the way, this is a really important topic for the final exam. The second time you wouldn't have an inverse is if A is not square. If you had a rectangular A matrix, then you can't have an inverse because you can't find the determinant. Okay, let's actually find the determinant. So we originally started a system of equations and we converted it to a matrix. So if we wanted to solve this system of equations using matrices, the first thing we want to do is understand that we have the setup of matrix A times matrix X equals matrix B. To find the inverse, you write A inverse times B. Remember, order does matter. Multiplication is not commutative. So we need to remember that we're going to take the inverse matrix and multiply it by B. So the first step in finding an inverse is find the determinant of A. So remember, your formula for the determinant of A was equal to take the multiplication of the diagonals, AD minus BC. So in this case, we would take 3 times negative 5, and we'd subtract away the multiplication of negative 1 times 2. That's going to give you negative 15 plus 2, which equals negative 13. So when we have the determinant of A, in this case, we have negative 13. That's helpful for now our inverse equation. So on the next slide, we have the inverse setup, where we have 1 over the determinant of A times the augmented matrix. Now we just calculated the determinant of A was negative 13. Now I'm going to augment the matrix A. Notice A up on the top is 3, negative 1, 2, negative 5. So we're going to flip the A and B location. So we're now going to call that negative 5 on the top corner and 3 on the bottom right corner. And then we're going to negate negative versions of what we already have for B. So negative, negative 1 is 1. Negative of 2 is negative 2. And now you have to scalar multiply. Yes, you're going to get fractions, so write a big matrix E underneath this. A negative times a negative makes a positive, so the first one you're going to get 5/13. The next one you're going to get negative 1/13. Second one you're going to get positive 2/13. And then the fourth term you're going to get 3 over negative 13. And this is A inverse. So now that we have A inverse, we're going to now multiply that with B. So step 3 in finding the actual solution is now we have A inverse times B. So when we multiply, remember we're understanding that this is originally matrix A inverse is a 2 by 2. We're multiplying it with B, which is a 2 by 1. So we check, can we multiply these? Yes, these two match. And what do we create? A 2 by 1. Now I like to set that up so I can see what I'm dealing with. That means I have 2 rows by 1 column. So I'm going to set that up so I see the visual 2 rows with 1 column. I'm now going to understand that I'm finding row 1 times column 1. So I'm going to take 5/13 and multiply it by negative 11. So I have negative 55/13. I'm going to add that to negative 10/13. I'll do that on my next step. Then I'm going to see that I'm finding row 2 times column 1. And so I'm going to have negative 22/13. And I'm adding that to negative 30 over 13. When I do that, I'm going to get negative 65 over 13. And on the bottom row, I'm going to get negative 52 over 13. Now, if you know your 13s, You might know that 13 times 5 is 65, and 13 times 4 is 52. So in this case, we have negative 5 is the simplified version of the top segment, and negative 4 is the simplified version of the bottom segment. So remember, this equaled matrix X, which originally was X and Y. So your solution to the system is negative 5, negative 4. And just like that, you finished by hand. So now, let's go into the calculator matrix. So what if I had you use your calculator to find the actual solution of X, Y, and Z? So first we're going to go over how to find the determinant using your calculator, but to do that we need to actually set this up into calculator ready form. So again, we're going to have our system. Now our system has 3 variables and 3 rows. So this time the first matrix is going to have a 3 by 3. Then we have our variable matrix, which is going to have 3 variables in it. And then it's going to equal the constants on the other side of your equal sign. So your middle column we always know is X, Y, Z because that's the variables we have in the system. And then the first matrices, the coefficients, so we have 3, negative 5, 4. Second row is 6, 1, negative 2. And our third row is 7, negative 4, and 5. We're going to equal that to our constants that are on the right side of our equation. So we have negative 11, 4, negative 2. So from here, what if we were asked to find the determinant of the square matrix, or matrix A in this case? Remember, this is matrix A. We're multiplying it always by matrix X. We're equaling that to matrix B. So on your homework, it might look like, if we had that set up, they might ask you to evaluate, and then it just looks like this: 3, negative 5, 4, 6, 1, negative 2, 7, negative 4, 5, with bars like that. So to enter this into the calculator, you're going to want to use your calculator skills sheet, or you can listen very carefully. If you grab your graphing calculator, you're going to notice the matrix word is above the inverse symbol. So if you hit second x to the negative 1, you should get this screen. Again, I'll point those 2 buttons out so we can see them. So you should get that screen, second x negative 1, and it gives you this screen. Now, to enter this matrix into that screen, you're going to scroll over to where it says Edit on matrix A, and you're going to hit Enter. Once you get to that, I'm going to go to my next slide so I can show you what I'm seeing. It gives you this option. Matrix A is a 1 by 1, but it's not. We know it's a 3 by 3, so we're going to hit 3, enter, 3, enter. And then it pops up a matrix that you can now enter your coefficients. So what you're going to want to do is now enter the coefficients of matrix A. When you do that, we then need to find the determinant. So again, you're going to type in your values. Make sure you only type 1 per element. And then to find the determinant, you're going to go back to your matrix menu and then arrow over 1 time to where it says math. Notice where it says math, you then have the option of DET. So we're going to go to our home screen. We're going to pull that math menu up to DET. So now on my home screen, it's flashing DET parenthesis. Now I'm going to hit second matrix again and just hit A, enter, and you should get something like this. This is how you would do a 3 by 3 on the calculator. Now, if we were continuing to find the actual values of the x, the y, and the z, we would need to remember that the formula to find matrix X is going to be A inverse times B. Now, we still haven't put matrix B into the calculator. So, to put matrix B into the calculator, again, you're going to hit second matrix, arrow over to edit, and then you want to put in a 3x1 on matrix B, and you want this to be the values of matrix B. So I put this in the top corner so you can see. Now that I have matrix B entered, I'm going to go to my home screen. And now on my home screen, I'm going to hit second matrix. Now I'm in the names column, and I'm going to hit A. I'm then going to put -1 as the exponent on it. And then I'm going to hit matrix again, and I'm going to put B next to it. So I'm asking you to put this in your home screen of your calculator. When you do that and you hit enter, it's going to give you a bunch of decimals. That's normal. I get these decimals based off of what I've typed in my calculator. And to get these into exact values, you're going to hit the button Math, enter, enter, and sure enough, you get this wonderful solution with actual fractions. So we now know that if we were answering the system of equations, we could say that x was 19 over 29, y was 124 over 29, and z was 61 over 29. Folks, that's the lesson at its finest. Have a great day.